Yeah, welcome back, guys. Again, it's me, Joey Monday. I'm still your tutor, so I'm really happy again to be back with you because we gonna start now with calculation. So we need to do some basic concepts that we need to recall. And the first concept that we are going to have a look on is the series second concept. But it's something that we've done, and I'm sure we're just gonna recall it so that once we start doing those calculations, you are not lost. And as I said, we're gonna do a basic concept, a revision on series second and DC second, and now we're gonna look at them when we are dealing with impedance. Without taking your time, we're gonna start already with our basic second. And then we can look already from the second it's a series configuration, as you can see. So when you talk about series is when you have such configuration, and here it's basically in a DC circuit. So one thing we observe is that the current that is coming from this battery, it's gonna be the same through the circuit. Can you see? So therefore, one thing we observe in the series circuit is that the current is the same across each resistance. But one thing we're going to observe is that the voltage drop is going to be different. Therefore, you want to apply your Ohm's law. You know your Ohm's law using the triangle. So you can calculate your V1, you can calculate your V2, and then you can calculate your V3. So your Ohm's law using the triangle is still simple, as you know. So it's all about this triangle. You have your voltage, current, and resistor. So for instance, looking for the resistor, what do you say? You are looking for the resistor. It's going to be the voltage divided by the current. Okay. If now it happened that you are looking for the current, it's going to happen that it's going to be the voltage divided by the resistance. And then if you are looking for the voltage, it's gonna be the current times the resistor. And as you can see, we say the voltage drop across each resistor, it's different in a series circuit. Okay, so using our Kirchhoff loop law, or can call it Kirchhoff voltage law, we know that the sum of the rise voltage, the sum of the rise voltage, like in physics, is equal to the sum of the drop voltage. And then what we mean by drop is the voltage across our specific component. Okay, so what happens is that our supplier will be equal to the sum of the voltage drop in a circuit. So you can see that V is equal to V1 plus V2 plus V3. So we're gonna be using this formula more often because it's really gonna happen that we need to use this voltage rise, voltage drop circuit for Kirchhoff. So you should be used to this already, and hope that you're gonna be used to that. And the last thing that, as I said, the current equivalent in the circuit is gonna be the same current. When you're calculating the total resistance, which is our equivalent resistance, it's going to be the addition of the three, because in series the resistance are going to add each other, and after getting the equivalent circuit will be that. This is in a DC circuit, but this concept doesn't go away. It is the same concept that we are going to apply in our AC circuit. But now the difference between the two is that our calculations are just in complex mode, whereby I've made a video for you how to do the calculation in complex mode. You have a magnitude and an angle, and this is called polar form, or if you have in this configuration, it's called rectangular form, plus or minus. So I've made a video already on how to do your calculation in complex mode, so you need to change. So basically the difference between AC and DC is just that AC, all the calculations are in complex form, but with DC it wasn't in complex form. So now we are going to move and do an example, but all these basic concepts about the series circuit still the same. Okay, so from this, now we are going to have a look on as I said, rise is equal to drop. We have explained already that. and now it's given by that. So now we're gonna have a look now in the series impedance. When we talk about impedance, is one of the video that I did to you, because those video was really important. And impedance is a combination of the three components: resistor, capacitor, and inductor. So I already made a video special to explain you how to get those impedance. And impedance, for instance, can be a combination of resistor and a capacitor. Already this is the combination of the two. It's an impedance. A combination of a resistor and an inductor. The combination of the two, it's our impedance. A combination of the three components. The three components, meaning the resistor and then the capacitor, it's already a impedance. Any combination of the three components, it made our impedance. So you should watch a video on this impedance, how to get the total impedance, so that when we start doing calculation, we don't go back anymore. Those videos will feel like it was boring, but it was really important, because it will be better for you to understand why are we doing this, why are we calculating this impedance like this. So go and do some recall again on how to calculate the total impedance, because once we start doing calculation, we just want to be forward. We're not going to go any more back to explain how do you get this, how do you apply that. No. Go and watch the video on how to calculate the impedance. What is an impedance? As I said, it's a combination of any of the three, and then in AC there is a way to calculate them. Okay, and there is already a video on it. And then we're gonna move. As I said, the concept didn't change. We're still in the same concept. As you can see, it's the series circuit, but now we are dealing with them in impedance. Those are our impedance. And then when you have to apply your Ohm's law is gonna be in the form of what? Of impedance. Remember, we have here what? The voltage, the current, and then you have your impedance. So basically, everything is the same, but just a small change in the components we are using. Now everything is in complex number. Our impedance is in complex number. So it should be used, as I said, the equivalent circuit is going to be the addition of the three. You apply your Ohm's law, and then the voltage drop is going to be difference, and therefore the rise voltage will be equal to the sum of the voltage drop. Same as in electrical one, but now we are dealing with complex number. And I need you to go and watch, I think it's our lesson 2 on the website. Go watch lesson 2 and do some recall on how to calculate the total impedance. The impedance is a combination of any component. So that is on our this small concept video. It was all about to show you how do we deal with series circuits, what is the difference between DC and NC, and the two, they are not really different.